Hello, good morning. Yesterday I had a discussion with Harsha, and in this session we am going to discuss about the data structures, and I will take the example of one coding question, which is the adding the two lists, with help of linked list. And this is the recording session, which is going to be delivered to my interviewer. And if you want to ask me any kind of questions, you can ask me. So this is the question. I would like to explain about the linked list, and before that, I would like to explain about the what is the use of linked list. So this is the question of my lead code, and I don't have a regular practice sessions, and I'm going to relate it with the real life examples. And generally, we use the linked list for doing undo operations and also to check the browser history to navigate to the next application, to navigate to the next browser, and to navigate to the your next application, and to go forward, to go backward. We use the different kind of linked list, like double linked list, if we take that circular linked list, whatever it may be. So here, this question is related to adding two numbers with the help of linked list. So here they have given that you are given non-empty linked list, means it don't have any negative numbers, and it is got stored in the reverse order. So it means that, so let's say imagine that I have list 1 here, I have list 2 here, 2, 4, 3, and 5, 6, 4. So after adding these two lists, you have to the resultant list might be 708. So for better understanding, I have took this diagram in my paint interface, and if you can consider this 243 and 564, I have replicated the same example diagram here. So let's say that if you add this 243 and 564, you will get that 807 as an answer. So but you need to store this resultant value in the reverse order, because of in my case, my example one case, my answer is 807, right, and my output is 708. So I need to traverse it, I need to traverse it from in the reverse order, and I need to store my value, my resultant value, from last value to first value. So I want to keep traversing from my last resultant value to first resultant value. It means that I want to pick my last value as 7, and I need to create the node, I need to store it in my new node of my resultant linked list, and I need to store this 0 in my second node, I need to store this 8 in my third node. For that, I'm going to create the resultant linked list here itself. I'm going to create the one resultant linked list as my new node. So let's say that, so I have created the resultant linked list here. So imagine I'm going to consider two variables, which is sum and carry, because of some of when we are adding the two, while we are adding the two numbers, we might get the carry as well. So that is the reason I'm going to take the sum and carry as well. So initially my sum is might be having with the 0, containing the 0, okay, and also I'll be having carry as 1, carry as 1. Not, it's not 1, it's a 0, okay. And let's say imagine that at this time I have created the resultant node here, result node here, result linked list. Initially I might be having a 0 here. I'm considering the 0 as my first node. So the reason is, some of nodes is might be having 0, some of nodes we might be having as a first result. So that's the reason. So you can consider, you can start inserting the value from the first node itself. In my case, I'm going to insert the 0 in my first node. So I'll be returning this second node from second node onwards from my function. So I'll create one pointer. I'll point to this from to my first node, to point to which will help me to point to the next further nodes. So for that, so in this case, I'm going to add, I'm going to keep traversing from my first node onwards. So here I have list 1 and list 2, two nodes as right. So in my list 1 of my first node, I'll pick my list 2 of first node. So in my case, I'm going to pick these two cases. So I'll pick this two node. I'll pick this two as a data from my list 1 of my first node, and I'll pick these 5 as a data from my list 2. And if I add these two values, I'll get my sum value as, in my case, I'll get my sum value as 7, right? I'll get my sum value as 7. Okay, 7. So in this case, I don't have a further two digited values, because of if I have two digited values, I need to carry the value. I need to store that carry value instead of my carry variable. So here I don't have a any two digited values. So that's the reason I'm not considering carry value anything further. And that 7, I'll for to store that 7 resultant value, I'll create one new node for my resultant linked list. I'll store that 7 instead of my result. Okay, imagine I have some addresses like my list 1 and list 2. I'm not going to write these addresses because of it's a waste of time. And I hope you understand how it is storing the addresses, how it is navigating. And I'll store these addresses as 7, and it will point to my second node with the help of pointer. And I'll move this pointer to my newly created node. Okay, and then after I'll move this list 1 to my second node to my second node. I'll move this list 2 to my second node. Okay, at this time I'm going to consider these two values. I'll pick this for this value. I'll pick this value. I will add these two values. At this time I don't have any such kind of element inside of my sum because of I added already here. And here what I'll do here is I will add these two values. You'll get 10 as answer, right? So here I got the two digited values. So I need to take the carry instead of my carry variable. So to do that, so I need to write one statement called carry equal to sum divided by 10. So which will help me to get 1 as an answer instead of my carry. So when I write this sum divided by 10, I'll get my instead of my carry, I'll get my answer as carry as 1 instead of my carry variable. So, and then after, if I want to add this 0 instead of my sum variable, you need to write one statement called sum equal to sum modulus modulus 10. So when you write this sum modulus 10, you will pick this 0 value, and you will store that same 0 value instead of some variable. So from that you are going to store final resultant value after carrying your value, after picking your one digit instead of your carry variable. You're going to consider your 0 as an answer. So this 0 I'm going to store, I'm going to store it inside of the new node of my resultant linked list. So here I'm going to create the new node of my new linked list, and then after that 0 which is inside of my sum, I'm going to store that value instead of my sum, instead of my resultant new node. So from that I have created the new node here, and I will, with the help of this pointer, I'll link this with the new node. After linking this, I will keep forwarding this pointer to my newly created node. Okay, I have moved this pointer to my newly created node. Okay, and then after, um, come back again, as previous what I have considered. You have to consider the same case here. So you are going to move forward this list to from the second node to third node, and here also from the second node to third node you are going to move forward your list to pointer. And then after, you're going to consider at this case these two nodes, and you'll pick this value as 3, you'll pick this value as 4, and you'll add those values inside of my sum variable. At this time I don't have any value here because of I have inserted the value already. And at this time my carry value is 1 because of in this previous case I have carry value as 1, right? So to do for that I need to write here as a 1. Okay, so 3 plus 4 is 7, right? So 3 plus 4 is 7. I got 7 as answer, and after getting 7 as answer, I need to check whether I have a value instead of my carry or not. If I have a value instead of my carry, I'll add that instead of for my newly created resultant value. And after adding that, I'll get my answer as a 8. I'll pick that 8 by performing these two operations, performing these two statements. I'll pick that 8, and I'll create the new node for my resultant linked list. I'll create the new node for my resultant linked list. I'll insert that 8. I'll insert that 8 instead of my newly created node, and that which is instead of my sum variable. And with the help of pointer, I'll link this these two nodes. These two nodes. I'll point to my further next node, or we can say that newly created node. At last, you will check whether I have a further nodes or not, and here also you will check whether I have a further nodes or not. And if you don't have a further nodes, my loop will be terminated. So to traverse this from my first node to till my reaches null, and from my list 2 to my from my for my list 2 of my first node to last node, to traverse this, I need to do that. I need to perform the operation. I need to take the help of while loop or any loop. Okay, and I'll take the help of loop, and I'll check the conditions whether I have a digit or not. And to do that, I hope you understand how the case is working here. Actually, I'll take you to that this coding session. I'll start to solve this one. And here we have a list 1, list 2 as a my to list. So you can consider these values as example. And for that, for first I need to create the result node, and I'll create the new result node. And initially I'm going to add 0 instead of my node. So in this case I have added the 0, but I'm not going to return this 0. I'm going to return from my next node. I'm going to return the address of from my next node onwards. So here also I'm going to create the 0 as my first node, so I'm not going to return that node as my resultant final value. And I'm going to create the one pointer, this node ptr, and I'm going to assign the same address of my result linker list, which is first node address. Okay, and then after I'll create one carry value equal to 0. Initially my carry value is having a 0, right? So after that, what I had to do here, I need to traverse this list 1 till first node to last node, and as well as I need to traverse this list 2 till my first node to last node. To do that, so I'll have to take the help of, in my case I'm taking the help of list 1 while loop, and list 1 till it reaches in null. And also, or else, if you're at least if your L2 or L1 is having some kind of nodes, you keep on traversing till your its last node of that linked list, and equal to null. You are keep on traversing that. So while traversing, you have to say that you have to add inside of your sum. You have to add inside of your sum your carry value before performing your operation. And then after, you have to check the condition inside of your list. Inside of your list, if you have any kind of value, if you have any kind of value, you will pick that value, you will add inside of sum. You'll add inside of sum. So in my case, my variable is val, right? So I need to take the help of val. And then after adding, you'll move forward your list. You'll move forward this L1 pointer towards the next node. So that is the case I need to perform here. So I'll move forward my list 1 to towards the next position, L1 dot next. So here I have a next as my pointer. Here I have a next as my pointer. That is why I'm taking the help of next. Okay, and then after, I'll check the same condition for my L2 as well. I'll check the same condition for my L2 as well, and I'll rename this from my L1 to L2, and here as well I'll rename this from my L1 to L2, and here as well I'll do this L2. I'll do this L2 because of we are doing the same kind of operation for L2 also, and we are going to perform this operation, same kind of operation. We are going to keep on traversing from my first node to last node instead of my while loop, so till it reaches the null. So then after, what I had to do, I have added instead of the sum, I have picked the value from my list 1, I have picked the value from my list 2, I have added in it. After adding, you have to, what you have to do, you have to do that, you have to check for whether you have a carry or not. If you don't have a carry, just neglect it. If you have a carry, just take out the carry, or if you just take out the carry and add inside of the carry variable. If you don't have any carry, just add that first digit instead of the sum variable itself. Got it? And I'm going to perform these two operations below this. So carry carry equal to sum divided by 10. If I have any carry or two digit values, it will pick that second most value, right? It will pick that second most value instead of your carry. And after that, if you don't have any second digit, two digit value, it will pick that for first digit itself. It will add inside of some variable. And this is the two operations um, which will help me to find out the carry and find out the sum values. And then after, if after finding the sum, I need to create the new node for my result. I need to create the new node for my result node. So here what I have did, after adding these two values, I have created the new node. I have created the new node, and after creating new node, that resultant value I picked that resultant value from my sum variable. I have inserted inside of this, right? So this is the same case I would like to do here. So I have created the new node. Whatever the value I have inside of my sum, that I am going to insert inside of my that value I'm going to insert instead of my newly created node. So this with the help of pointer, with the help of pointer. So here we have a pointer, right? With the help of pointer, I'm going to update this data, update whatever the data I have here. This data I'm going to update here with the help of pointer. So to do that, here I have that new node. I have created new node. So with the help of pointer, I'm going to store that address of new node. Okay, and then after doing this all such cases, I can easily take out my solution. And after that, let's consider that second case. imagine i have a Imagine I have a this case. Let's say that let's say that you have three nines. Let's say that in you have three nines here, and you have two nines here. Okay, and after doing these things, if you add these two numbers, you will get as a here you will get as a 18, right? And here you will get a carry as 1, and you will get 18, and you'll get 19 has, because of carry you will get 19 here, and you'll get 10 here. You'll get 10 here because of the carry again. So in my case what I would like to say here is, so in your first list, imagine this is your first list elements, imagine this is your second list elements. In your first list elements you have three elements. In your second list elements you have only two elements. So in my resultant case, I got that four elements, right? So you have to consider this case also as well. So be careful about this. So imagine in my last case, my query is having one. So I need to check until last. I still my carry is having with one or not. So to do that, so I'm going to check here if my carry is still having. If my carry is still having one, then on those cases I need to create the new node. I need to create the new node. On those cases, I need to create the new node. I need to insert that resultant carry value instead of my newly created node. And after creating the new node, I need to update instead of my. Let's say that I have one here. One I got remain with I got left with one as a carry at last. There is a no need of calculation at last. So that one I have to add at last here. In this case, I need to create the node. I need to add one as an answer instead of my newly created node. And with the help of pointer, I need to link with each other. So here as well, I'm going to do that same thing. In the pointer next, picker next. With the help of picker next, I'm going to update the addresses, and with the help of my newly created node. And this is the same thing I would like to do. And after this, I'll return. I'll return I'll return my resultant linked list from my next node of address. I won't return my first node because of I have a zero here, right? So I won't return this. I will return this second node of my address. So after performing such cases, so at last, what I will do here is I will return. I will return result dot next, because of at first node. In my case, at first node I have a zero. If you see that at output you don't have a zero as a first resultant node value, so you have to consider this case. So I'm going to return my second node onwards because of my answer in this format, and not in the format of 0708. So that is the reason I'm returning my result dot next onwards. So by considering all of these cases, I'm going to run this code. Let's check this. Yeah, I forgot to update this PTR next, PTR equal to PTR next. This is the case I forgot to update, and the rest of the thing is same. If you submit this, you'll get the right output. Yeah, you can see here. So thanks for inviting me, and especially I would like to say that linked list we use everywhere in browsers history and in stacks, in graphs, and in maps. We use everywhere, and especially if you ask me the time complexity of this code, I can say that order of n, and space complexity also it is taking order of n. Okay. And if you ask me that what is a real life application of adding two numbers, let's say that you if you have that large numbers, if you want to add in large numbers, and to do that in highly precision, if you want to get the highly precision values, let's say that in cryptography and in file management system, in scientific calculators, we use this related questions on those applications especially. And also especially we have double linked list and circular linker list, and which is related to tracking the browser's history. And also we have video player forwarding, backwarding, and doing undo operations. We use this kind of linker list because of linker list is a memory efficient. And thanks for giving me this opportunity. I hope you got understand with this my case, and thanks for that.